So I'm going to talk about IPv6 transition technology, which is probably a huge topic that everyone's got to think about if you work. Thank you. If you work in the access space at all this year, because as you've seen this week, one of the larger service providers in the UK has announced that they're planning to start carrier grade NAT trials, transitional technology trials, because IPv4 exhaustion is upon us, and actually the provider got an awful lot of stick in some tech circles, but I thought it was quite brave of a provider to be quite realistic and say we're going to be the first, we're going to do some trials, we're going to try and make things work for our customers in the long term. But these are my thoughts on transitional technology. To kick things off, I thought it would be useful to define what transitional technology was, and the definition on Wikipedia I thought was a fairly reasonable one, where transitional technology was defined as technology to facilitate the transition of the internet from its initial and current infrastructure to the successor addressing and routing system of IPv6. I didn't really like that definition. I thought I much prefer something along the lines of crappy little hacks that add a new cost burden to ISPs, hurt the end user's experience, and disrupt the pace of innovation at content producers. That's a better definition, in my opinion. However, let's be realistic. Let's face facts. Transitional technology is necessary because we're out of V4, and yet we still have to keep adding users. Otherwise, we can't keep adding revenues to our companies. So I think it's probably useful to say if transitional technology is important, is something that we need to support, let's define some features that would be useful in transitional technology so that we can measure whether transitional tech options we have today meet those needs, those features. And the features that I would advocate are that they are a step towards native IPv6. They allow end users to sidestep carrier-grade NAT altogether if V6 content or services is available. That one day we'll be able to turn off this transitional tech, and that it works at enormous scale. And the key point, I think, about transitional technologies, the most important feature, is that you must be able to turn it off. That's key, because if you can't turn off the transitional features, the carrier-grade NATs or whatever one day, it becomes a new cost of doing business. Transition implies temporary, and therefore it must be something that we can turn off. So let's measure all of the transitional tech options against these definitions, and we'll start with Nat64. Well, does it pass the test? Well, in my view, it's not transitional whatsoever. Adding layers of NAT between your users' devices and your core network and your edge of your network is not a transition. It does not give us a path towards native IPv6. It's a buy now, pay later, and later, and later technology. It may, in fact, for that reason, be your vendor's preferred solution. And in fact, NAT444 does have some traction and is being tested by ISPs because it's a fairly logical default position that if we don't do any more work with V6 is something that we have to make work. But if even if NAT44 can work for access ISPs, what do all of the content ISPs in the room do when they face the last of exhaustion issues? Worst of all, the only possible outcome for NAT44 is more NAT, more boxes, and more cost to you as ISPs. So does DS-Lite pass the test? This is a better system because if it provides access to V6 native content or dual stack content via V6 without having to use V4 tunnels or V4 NATs to reach the content. So it does provide a step towards V6 native services, but is this really the best solution? And I would argue not, because DS-Lite is fairly non-deterministic. If you have a piece of content, if you have an asset which is available via V4 or V6, how will traffic be routed? Will it be routed via the V4 tunnel, or will it be routed on V6 native? And are you absolutely sure it will always be routed in that way? You want requests for dual stack users to be delivered via v6 address when it's available, to avoid the request transition in your NAT. But will it actually always follow that path? Well, the work on Happy Eyeballs, which is a feature which is built into browsers and modern operating systems now, has caused routing to become less deterministic and for operators to be less sure about whether the path taken will be a v4 or a v6 path. So you may well find that traffic to a v6 enabled host from a v6 or a dual stack enabled customer passes through your v4 NAT, because browsers are not deterministically picking v6 when v6 is available for sure. I don't want to restate all the work that Jeff Houston did on this, but if you look at the RIPE64 website, you can download his presentation where he shows a comparison of all of the operating system and browser behavior, and it shows that even where he has good quality native v6 and good quality native v4, the traffic will take a path which is almost random in a way to because the best intentions of the Happy Eyeballs protocol is to ensure that users don't experience a failure if the v6 path is non-functioning, inelegant, or worse than the v4 path. But it doesn't give v6 the head start required to use native v6 where it's available and working in a reliable way. So if we use DS-Lite as our transitional technology, even when your users are dual stacked and content companies dual stack as well, the very likely outcome is still more NAT, more boxes and more cost. Does 6RD pass the test? Well, here the ISP runs a service where v4 is supplied natively to the end users, and they run gateway services to deliver v6 content or v6 only content to their eyeballs. What happens when v6 traffic grows under this scenario? Does it seem counterintuitive to anyone in the room that as we add more v6, the ISPs have to add more v6 6RD gateways as time goes by? The best possible outcome here again is lots and lots and lots of 6RD relays and complexity and cost. There's a new v6 transitional technology which was proposed last year, which actually I like an awful lot more because it borrows features from A&P, the A&P carrier grade NAT alternative, which is where the sending port of a user becomes part of the v4 address, so that a user may get a bank of 1,000 ports for their home or office, and the address, the port becomes part of their address, so that although users are sharing v4 addresses, the state doesn't happen in the ISP. They know that if it's ports 1025 to 2048, then they know that that's for that customer, the next 1,000 for that customer, etc., etc. So the ISP doesn't need to track state, which is much simpler, much cheaper to deploy, and much better for the end user because it can allow inbound connections. But in my opinion, the map system, although it's much, much better and has significant advantages, it doesn't actually solve the address exhaustion issue. We still have 4 billion v4 addresses at best, 8 billion people in the world and growing, and we basically need to address each of them in the future so that so that everybody can connect to the internet. It doesn't actually solve the address exhaustion issue. So map becomes pointless without dual stack anyway. And there's still a risk that as time goes by, you will need to add more and more boxes to your network. Why is this so difficult? Nat64, does that pass the test? Here, the ISP has to translate v4 traffic, which we all agree and acknowledge v4 traffic is growing in volume today. But what about the future? Where do we want the growth of the internet, the growth of traffic on the internet to actually be tomorrow? There's a nasty performance flashpoint as the ISP tries to scale its NAT64 gateway infrastructure. But there's no nasty performance flashpoint when users use native v6 on their domestic connections and reach a dual stack service or a v6 only service. The way that Nat64 works, CPE in the user's premises only has a v6 address, so it steps around the happy eyeballs or the v4 NAT might be selected over a v6 native issue that other transitional technologies have. And by allowing ISPs to, or if ISPs are forced to produce a nasty performance flashpoint in the form of a v4 NAT gateway, but no performance flashpoint with a v6 connection, there's an incentive for people who host content to offer it via native v6 or dual stack anyway. So this transitional technology, if we look at the measure of the features that we like, is a genuine step towards native IPv6. It provides a real incentive for people to deploy IPv6 if they're a content generator and an ISP, and it helps to grow the amount of v6 traffic on the internet. The best possible outcome is that the Nat64 estate can, in the future, be reduced or even turned off. But there are breakages with Nat64 which don't exist with other transitional technologies, such as people who use services hosted on IP literal. So if you host a service and you say this resource is on 10.10.10.10, there's a v4 address, then that service won't work with Nat64. So end-to-end v4 only apps cannot function. Does this really mean that all transitional technology is flawed if there are problems with all transitional tech? Well, no, but it does mean that we get the internet that we deserve. This is quite a forward-looking presentation, in my opinion. It's a presentation that seeks to address where do we want transitional tech to be in 5 or 10 years, rather than today. And we have to answer, or we have to ask ourselves the questions, where do we actually want to be at that time? How, in our transitional technology, do we provide an incentive for content generators to make their services available via dual stack or native v6? And what transitional technology, if we're spending all this money on transitional tech as well, shouldn't it be a technology that encourages us to upgrade end user connections? So this is the future that Nat64 brings. It isn't a It isn't a technology that's ready today, just like all of the transitional technology, but if we have to pick a future transitional technology in 5 or 10 years, I think this is the best technology because it provides a future without transitional technology. Are there any questions, opinions, responses to controversy?
Tom Bird from Portfast. Does it work with DNSSEC yet?
So there are this actually came up when we were talking about this at the Right meeting, and it didn't until last year. I believe that there's an extension to DNSSEC that allows this to work, because the way that Nat64 works, you run a DNS64 gateway in your network that when somebody queries the address for a resource record that only has a v4 and a record to reply, the DNS 64 box gives a spoof v6 address which points to an address that will allow you to reach the v4 service via Nat64, which means that you're playing with DNS on the wire, which breaks the original DNSSEC implementation. But in order to work with DNS64 and Nat64, there's an extension being pushed through, or not pushed through, but debated and worked through by diligent protocol designers in the IETF.
Okay, we'll have it by 2020 then. Thank you.
Thanks.
Any other questions for Andy? Mike.
Thank you. Oh.
It's like a pantomime. It's behind you. Mike Hughes. I'll wear my 6 Connect hat. It's quite a new shiny hat. Quite relevant. I think one of the things here is whatever's going to happen, it sounds like we're hell-bent on changing one of the fundamental things of the internet, which is the complexities around the edge. You know, the complexity and the state is around the edge, and less so in the centre. And I think you've just if we're going to end up in a situation where we've got to, because I mean the most common one is we're in a situation where your grandma won't upgrade her Windows XP machine or something like that, or you've got people with just unupgradable technology, and trying to get that out is a nightmare anyway. But I think that anything that means that we've got the least complexity in the middle has to be good, is my opinion, because otherwise we're just saying, well, hang on, we're just fundamentally changing the properties of what the internet is, which is an edge complex system.
Yeah, absolutely. If the internet doesn't scale with complexity in the middle, we've seen experiments over the last 20 years with things like flow-based routing and other technologies that add all of this state and core into the middle of the network, and we scale. State in the middle is bad. A large office, a large enterprise without state on their network can probably outperform a medium-sized ISP with state in the middle, and that's what the future of transitional tech will do if we don't pick as a community, as an industry, a technology that one day we can turn off. So in my opinion, all of the transitional tech we have today is interesting, all deeply flawed, and whatever we actually design that can help us translate or can help us transition from V4 to V6 is the tech that we must pick, the one that doesn't have state in the middle, doesn't have state in the ISPs, and one day can be turned off so that we can have an internet that's only as complex as the one today. Hey.
Okay, Andy Hutton again, Siemens. I might lack some knowledge in here, so I apologise, but the ITF, I'm involved in the ITF quite a lot, seems to back happy eyeballs, seem to be the way forward. And I think the reason for that is that we want to encourage content providers to turn on IP version 6. And also want the best possible user experience. We don't want users to blame IP version 6 for bad experience. And at the same time, we want end-to-end IP version 6. So I think happy eyeballs is a good solution. And to be honest, in the SIP world, we're talking about happy eardrums, doing exactly the same thing in the SIP world. And mainly that is basically just to reduce the timeouts on IP version 6, so you fall back to IP version 4. Isn't Nat64... another issue is really is that to be able to turn off IP version 6, IPv4, and it'll all be seamless one day. Doesn't Nat64 really sort of get in the way of maybe reduce the incentive for content providers to turn on IPv6?
Okay. So those 2 points I'll take in turn. The happy eyeballs, I agree is a good. I do agree is a good methodology, because it has enabled content companies to turn on dual stack services where they didn't have the confidence to before. But I think that the default happy eyeballs implementation is too quick to fall back from V6 because home internet connections don't behave like the ones in the lab, and I refuse to believe that it could be possible that anything that picks lumpy V4 NAT via NAT is a better performing and better user experience than V6 native, but there was some OS bug that meant that DNS request went off half a millisecond later or something like that. I think that the fallback happens too quickly, and also because the happy eyeballs methodology hasn't been implemented consistently between all browsers and operating system vendors. It means content companies trying to debug issues mean that they have a situation where they might make something better for this guy and worse for this guy because all that happy eyeballs is a methodology rather than a protocol, and it's different on every system out there. So my dream would be a happy eyeballs world, but was less quick to fall back to V4. So that we can confidently roll out dual stack services that will be used in preference to transitional tech NAT. That would be my preference. The second question regarding whether Nat64 removes the incentive for content companies to upgrade, I think it provides a greater incentive for content companies to upgrade, because the question we face, or the question faced today is, should you turn on dual stack services? This might happen, this might happen, this might happen. In a future world, if we have widespread Nat64 deployment, we can say to content generators, if you turn on dual stack services, the lumpy NAT goes away. And we provide a very, very, very clear incentive to content companies to turn on dual stack, because then their location-based services start working again, because they don't see an entire ISP behind a small number of addresses. And their ways of, and also the NAT splodge in the middle isn't slowing down user sessions, and they'll be able to turn on more interactive services to users again, because suddenly they have a lot more ports to people and can have more synchronous connections on the website or inside their application or whatever. Lots and lots of reasons for end-to-end, and all of those become available to content companies who upgrade to dual stack in a Nat64 world. So that's my view there. Maybe it's optimistic, maybe it's true. I hope it's both. I hope it's both optimistic and a forward-looking view of the internet. But time will tell. We'll get the internet we pick as an industry.
Okay, I have a question off the IRC room, which is now scrolled past, so I can't remember the exact words, but it was basically about CPE vendors in Nat64, what's being done on the CPE vendor front. So
CPE vendors don't need to implement anything cleverer than V6, the way that V6 is done today to support Nat64. So we're not saying you need to support this tunneling technology. You don't need to support 6RD in addition to V6 and this. We're saying if you support native V6, the ISP gives you a native V6 connection and does the fudging to get you onto the V4 internet. So CPE vendors need to do nothing other than what they should be doing anyway.
Okay. Right, one more question, and then we need to move on.
Hi. Yes, Darryl Tanner. You say Nat64 is maybe sort of 5, maybe 10 years' time. What do you see in the shorter term?
It depends how we're webcasting, and I'm about to say it depends how big a lie everyone told to the RIPE NCC when they were getting addresses, doesn't it? Because if anybody has addresses in the next 6 months, it means they told a lie, doesn't it? But I suspect that people will still have native or public V4 addresses to give uniquely to their users within the next 6 months, so therefore I don't think people will be rushing in to having to roll out transitional tech this year, even if they're making decisions about what it will look like this year. The immediate future is probably one that involves V4 NAT, V4 state in the service provider network. There's probably no way around that. It's probably too late to avoid that at some point. My hope is just that we can turn this off one day. That's the point. That's the point I'm trying to make. That although we might have a few lumpy years where it hurts content innovation and it hurts your budgets in other areas because you have to go and buy all of these NAT boxes, make sure you always have an eye on transitional tech options for the future that mean you can take out that NAT estate, use those boxes for something else, use the footprint for something else, even if those boxes won't do anything else. You can always burn them on a bonfire when we're not doing NAT anymore, V4 NAT. But that in order for that to be an option, we have to do something that provides a V6 native future. Does that answer the question? I know I waffled a bit there.
Yeah, thank you.
Okay, thanks. All right,
Okay,
thank you.
thanks, Andy.
Thanks.